Today we discuss about work, power and energy. So in the chapter today we discuss about work done. What is work done? Work done means it is a product of force and displacement is called as work done. So in this chapter, work done means work is always said to be done by a force. It is the product of displacement and component of the force along the direction of displacement. So in this case, if we consider a block of mass m, it is lying on a horizontal floor. Then a force, a constant force acting on block m, making an angle theta with the horizontal. Then this block is moving some displacement, this one. So here S is the displacement covered by the body. So in this case the work is done. So that means here work W equal to the product of the displacement and component of force. So here F cos theta. So therefore Fs cos theta. So in this case here F is resolved into two components. So that is Fx along the direction of x-axis, that is F cos theta. Here Fy along the direction of y-axis. So in this case the work done is defined as the product of displacement. So here F cos theta is the component of force along the direction of displacement, is called as work done. In the case of work done, having the same dimensions of energy. So here in this case of work done, its a dimension formula is ml square t power minus 2. So in this case F into S. So here F means ml t power minus 2 is the dimension formula of the force, and S means displacement. So therefore W equal to m L into L square t power minus 2. So this is the dimension formula of the work. Now what are the units? In the case of units, SI units is joules. SI units is joules. CBSE units is ergs. CBSE units is ergs. Now the work done may be positive or negative or 0. Okay. So in the case of work done, why? Because work done is positive or negative or 0. So it is mainly depends on angle between the force and the displacement. So here work done may be positive or negative or 0. It is mainly depends on angle between the force and displacement. Okay. First of all, first case is work done is positive. Case 1. Case 1. Work done is positive. So here work done is positive when theta is less than 90 degrees. So then work done is positive. So in this situation, if theta equal to 0 degrees, then the work is. So therefore W equal to, we know that work done is also defined as the dot product of force and displacement, that is Fs cos theta. In this case, W equal to Fs cos, here theta equal to 0 degrees, cos 0 equal to 1. So therefore it is a positive. So in the above case, we can explain one example of that. First one, it is when a block is arranged on a laying on a horizontal floor, then a lifting force is acting on the block when the block is raised certain height. So when the force is acting on the block raised certain height, then gravitational force acting on the block is downward direction. So in this situation, the lifting force is acting upward direction and the displacement covered by the particle or block are upward direction. So in this case, lifting force upward direction, displacement also upward direction. Then work done by the lifting force, work done by the lifting force, W equal to here Fs cos 0, because lifting force acting upward direction, displacement covered by the particle also upward direction, then the angle between lifting force and displacement is 0 degrees. So here W equal to Fs cos 0 equal to 1. So therefore F equal to mg into here S. So here F is balanced to the weight. So this is the case 1. Now work done is negative. Second case is work done is negative. Case 2. Work done is negative. So in the case, the angle between force and displacement is lies between 90 to 270 degrees. Then the work is negative. So in this case, if theta equal to 180 degrees, then work done is, so W equal to Fs cos theta, here theta is 180, cos 180 is minus 1. So therefore minus 1 into Fs, that is minus Fs, then the work done is negative. So now we can explain this case, one of the example. That is, when a block is arranged in a horizontal floor, a lifting force is acting on the block, it raised certain height. In this case. So now gravitational force acting on the block is downward direction. So now in this case, the work done by the gravitational force, not only lifting force, work done by the gravitational force, by the gravitational force, W equal to Fs cos 180. So in this situation, gravitational force acting downward direction, but displacement here H acting upward direction. So these are the anti-parallel vectors. So here theta between the force and the displacement is 180 degrees. So therefore cos 180 is minus 1. So W equal to here F means mg, it's a gravitational force, mg into s into minus 1. So here s is equal to h. So therefore minus mgh. So the work done by the gravitational force in this situation is W equal to minus mgh. Okay. Next one, work done is negative case. Case 3. Case 3. Work done is 0. So here case 1 is work done is positive, case 2 is work done is negative. So case 3 is work done is 0. So here work done is 0, then the theta is 90 degrees. If theta is 90 degrees, work done is 0. Because W equal to Fs cos 90. Cos 90 equal to 0. 0 into Fs, 0. So in this situation, we can explain one example of it. That is, when a particle is revolving a circular motion in this way. So here, when a particle is revolving in a circular motion of radius r, so here the centripetal force is acting on the particle in towards center of the circle, but displacement is directed tangential position. So at this point, centripetal force acting towards the center of the circle, but displacement acting tangential. So here centripetal force and displacement are making an angle theta is 90 degrees. So therefore the angle between Fc and S are 90 degrees. So therefore work done by the centripetal force, Fc S cos 90. So here cos 90 equal to 0. So work done equal to 0. So in this case, the work done by the centripetal force is 0. So these are the work done may be positive, negative or 0. It is mainly depends on angle between force and displacement vectors. Okay.